Common logarithms. These are the only logarithms. This and ln of x are the only two you will see on your calculator. You don't have log base 3, log base 4, log base 5. And I will show you why. We write log base 10. We don't put the 10 on there. We just write it log of x. Just like if I say the square root of x, do we write the 2 up here? No, we don't. So we don't put the 10 down there. It's just understood to be the common log. This is fantastic because using logs, you can do what's called change the base. First, there's a couple up here though. Log base 10. Log base 10 of 1. 1 raised to what power? Sorry, 10 raised to what power gives us 1? Shout it out.
0.
0. One person knows. Log base 10 of 10. 10 raised to what power gives us 10? 10 raised to what power gives us 1,000?
3.
3. You'll notice this is also the number of zeros, right? Easy? Okay. Once again, you won't find log base 3 on your calculator anywhere, or log base 5 on your calculator anywhere. It's because we can do what's called change of base formula. This right here is huge. This is the big idea. Okay? It's the big idea for today. If it's log of some base, log base something b of n, we can rewrite that the log of n divided by the log of b. We're using base 10. We can use any base, really. We can use base e, which is ln of x. You will also see that on your calculator. Here is a short proof of how this works. If x is equal to log base b of n, we would all agree that b raised to the x is equal to n, correct? Put your pencil down, just watch this. I'm going to hit both sides with a log, and b with a log. Log base 10. So now I have log of b raised to x is equal to the log of n. But by our properties of exponents, this can come down in front, can't it? So I get x times log of b is equal to the log of n. Now my goal is to find x, right? So I just have to get rid of this somehow. It's x times log of b. How do I get rid of it? Divide. X is equal to log of n divided by the log of b. This is fantastic because this is actually something we can do on our calculator. We can do log base 10 on our calculator. All right, you may start copying again. Let's try the following. Log base 3 of 81. Now we know that we know automatically this is going to be 4. Because 3 times 3 is 9, times 3 is 27, times 3 is 81. So this should be 4. Let's check using our calculator. Type into your calculator the log of 81 divided by the log of 3. And you've got it there.
It says syntax error.
You typed something wrong then.
Oh, there we go. I didn't close parentheses.
It work? It says 4, doesn't it? You can also do it with ln. There's a button there for ln, which is the natural log, or log base e. Try the ln of 81 divided by the ln of 3, and you should get 4. Okay? It worked. So for all the times that you're like, well, how do I change, I can't find log base 3 of 7 on my calculator, Mr. Kuhne. There's no log base 3. Don't need it because it's right here. So how would I write this one? Yes, ma'am. Log of 7 over log of 3. Type that into your calculator, tell me what you get. .77?
Yeah.
77123. Okay. Now let's just do a quick check. Try it. Type in your calculator. 3 raised to the 1.77123. See if it's really, really close to 7. Pretty close, right?
Yep.
All right. So, you were waiting for this, weren't you? You're like, there's got to be a way on my calculator to do this. And there it is. 3 raised to the x is going to give me 15. 3 raised to the x is going to give me 15. How can I find x? Well, there's a couple different ways we can do this. What do you want to hit it with first? Log base 3 or log base 10? I don't care. Log base 3? Sure. 3 raised to x is equal to 15. Log base 3 of 3 raised to x and log base 3 of 15. What's log base 3 of 3 raised to the x? These just undo each other, right? Logarithms find the exponent. So guess what? That's just x. Now how do I find log base 3 of 15? Change the base. Log of 15 divided by the log of 3. If you want to leave it there, that's the exact answer. If you want to type it into your calculator, go ahead and type it into your calculator, and you get approximately what?
2.464.
Are we happy? Yes? Pretty simple? What if I change this to x minus 2? Would you freak out now? No? We're actually going to do this one a different way. 3 raised to x minus 2 is equal to 15. I'm going to hit with log base 10. What can I do to this exponent right here? I can bring it down in front. X minus 2 times the log of 3 is equal to the log of 15. Remember, this is just multiplying. So that means this is going to give us, if I divide both sides by log of 3, I get x minus 2 is equal to the log of 15 divided by the log of 3. So how do I find x now? I add 2 to both sides. X equals the log of 15 divided by the log of 3 plus 2. Easy? Not super tough? All right. right, this one. Super annoying. This one's annoying because I have two different bases, don't I? So, it doesn't mean it's impossible. It just means it's annoying. Put this out of the way. I'm going to beat both sides with a log. I'm going to beat it with log base 10, just because it's easiest. So the log of 3 raised to 2x is greater than or equal to the log 6 raised to x plus 1. What can I do with these exponents? According to our properties we learned yesterday, I can bring it down front. Two x times log of 3 is greater than or equal to x plus 1 times the log of 6. All right, from here you kind of have an option. If you want to get an exact answer, you don't actually type in, you leave the log of 3 there and you just treat it like anything else. If you don't like that though, because the math gets kind of annoying and gross, you can always just type in log of 3 and get the big long decimal for x. So let's go ahead and do that one first. What is the log of 3?
0.477121.
477121. You mean like 2 more digits?
2547.
2547. Okay. Times 2x. Let's go ahead and double that. Take it right now and double it.
0.954242509.
95425.
No, 2425.
2425.
9094.
094. X is greater than or equal to. Find the log of 6.
0.7781512506.
And all that's times x plus 1. Well, now we just need to take the original and subtract the x's from it, right? And then we'll need to divide. You can solve it from there, yes? It is a big, disgusting, gross decimal, isn't it? You can do it that way. If you don't like the decimals, I'll show you another way right now. Okay? The other way isn't necessarily easier. Okay? We are big kids now, so you can either use the big long decimals. Can't I just round to 2 places beyond the decimal? No. No, you can't. You're big kids. Because if you round early, all the rounding errors can count, and you run all sorts of things. Unless you want to start doing significant figures. No, I didn't think so. Okay. I'm more of a physicist than I am a than I am a chemist. And in physics, they don't use them. All right, so same thing. Bring a 2x down. Log times the log of 3 is greater than or equal to x plus 1 times the log of 6. So, we have to get all the x's on one side, correct? I'm going to go ahead and distribute this. Log of 6 times x plus the log of 6 times 1. This is all equal to 2 times the log of 3 times x. Give you a moment to look at that. Do you see what I did there? I distributed the log of 6 to this and the log of 6 to this. I just didn't do it as a big, long, nasty decimal. I took the log of 3 and I doubled it. I just didn't do it as a big, long, nasty decimal. So now we would want to get the x's on the one side, correct? So I'm going to subtract. So I've got 2 log of 3 times x minus the log of 6 times x is greater than the log of 6. 1 times the log of 6. Now you say, okay, how do I subtract those two?
You divide the 2 log of 3 by the log of 6.
I can't do it quite yet. I gotta get the x out of there. So I'm gonna factor out the x. 2 log 3 minus log of 6 is greater than the log of 6. Now, if this were just, let's pretend for a second, this were just 2x. 2x is greater than 6. I would just divide by 2, right? I'm just going to divide by the number in front of the x. X is greater than the log of 6 divided by 2 log of 3 minus the log of 6. Is it big, long, and gross? Yeah, kind of is big, long, and gross. But get over it. Okay. Now, could we combine this? Yes, we could. You can take this. This is where your answer might be, your answer you get might be look different from the one in the book, but it might be the same thing. Because I can take this 2 right here and make it an exponent, and get the log of 9 minus the log of 6. The log of 9 minus the log of 6, well, it's the log of 3 squared minus the log of 6. I can combine those to make it the log of 3 squared divided by 6, which is equal to the log of 9 over 6, which is the log of 2/3. So I'm going to have the log of 6 divided by the log of 2/3, which is also, if I change the base back, log base 2/3 of 6. So this can all be written like so many different ways. Oh, 3/2, thank you. Not 2/3, 3/2. Thank you, sir. So log base 3/2 of 6. This has got, these logs can get all sorts of crazy. There's about a billion different ways you can write the exact same answer. All right? So these are the big nasty problems. These, not so bad, right? If I've only got one base, the exponent equals a number, easy to solve. but I've got two different bases. Okay? But the big idea here is change the base right there. Change the base. Beat it with a log and a common log. Okay? Common log.